Welcome. This is Chapter 5, Day number 4 notes. This is talking about using point slope form. So let's do a quick little recap here and recognize that up here at the top, I have rewritten y minus the y coordinate of a point equals m, the slope, multiplied by x minus the x coordinate of a point, where that point would be x sub 1 comma y sub 1. This is a review of what we had done on day number 3 notes with our introduction to point slope form. The advantage of point slope form is that it allows you to graph or write an equation when given any point, not just the y-intercept. That would be the limitation of slope-intercept form, is you'd have to use the y-intercept for that b value, not any point. So let's go through and walk through this problem here. I'm going to come up here and rewrite our point slope form above it. And we are going to identify here the slope in the problem. The slope in this problem here is that number 3. That multiplier there is telling me the rate of change by which we are moving. You could write that as 3. If we're talking about it as a ratio, it would be 3 over 1. If I want to take a look at the point, I would like to emphasize here that in point slope form, it is y minus the y coordinate and x minus the x coordinate. So when I take a look here, what number are we subtracting? The number we are subtracting is a positive 1. When we look at the y-coordinate is going to be y minus the y-coordinate. The value that is being subtracted is again a positive 5. That means that my ordered pair, which would be x sub 1 comma y sub 1, x coming first, is 1 comma 5. If we'd like to graph this, the first thing we're going to do is plot the point. And then after that, we're going to use the slope to find two other points. So let's plot this point 1 comma 5. And then with a slope of 3, we're going to go up 3 and over 1, or down 3 and left 1. Grab ourselves a straight edge, make that line straight, and there is our line with a slope of 3 passing through the ordered pair 1, 5. I'm going to slide down here to example number 2. And we're going to write as y minus the y coordinate equals m times x minus the x coordinate. First off, we are going to identify the slope. The slope is the multiplier in the front, which in this problem here is negative 2. If we want to write it as a ratio, it is negative 2 divided by 1. Or we could write that as 2 divided by negative 1. We do need to be a little bit more careful here, because as I take a look at this here, this at the top says y minus y sub 1. This says y plus 2. So in order to write a y plus 2 in terms of y subtracting a number, we need to write it as y minus negative 2, because we do recall that subtracting a negative is the same as adding the positive. And that will, again, allow us to state the point. We do not need to worry about this with the x minus 7 because it's already being written as subtraction. So as I take a look here again, I'm going to highlight some things to recognize them. It's what value is being subtracted from the x. That there is going to tell me x sub 1 is 7. And if I take a look at what value is being subtracted from the y, the value that was being subtracted was a negative 2. That is telling me that my point would be x sub 1 was 7, y sub 1 is negative 2. If I would like to graph this, I'm going to follow these same steps that we had up here. So I'm going to plot the point at 7, negative 2. 1, 2, 3, 4, 5, 6, 7. That's 7, negative 2. And then I'm going to use a slope of down 2 and over 1. And down 2 and over 1. Again, here's my 3 points that make up a line. And we are in business. Let's do this one more time down here in example number 3. I'm going to remind you that it is going to have to be written as y minus the y coordinate and x minus the x coordinate. As we get ready to write this, we have y plus 6 here, but I don't want to leave it as y plus 6. I need to adjust it and call it y minus negative 6. And likewise over here, this is going to be x minus negative 1. Again, the reason for that is because we have to follow the form, and the form is presenting it as subtraction, so we're going to adjust ours to be subtraction as well. As we state the slope is going to be 1/2. As we state the point, remember that point here is going to be x sub 1 comma y sub 1, where x sub 1 is, I'm going to do some highlighting, is a negative 1, and y sub 1, the value that is being subtracted, is a negative 6. Please recognize that both of these were the opposite of the positive 6 and the positive 1 that were in the initial problem. Again, this is really important because negative 1 comma negative 6 is that specific point right there. We need to make sure that point is accurate, otherwise we'd be graphing the wrong line. And then I'm going to use the slope of up 1 and over 2, and up 1 and over 2. And we can graph our line that passes through negative 1, negative 6 with the slope of 1/2. If we would like to continue on here, now we're going to write the equation given a graph. When we are going to write the equation given a graph, if I notice these directions here, it says pick a point other than the y-intercept. Well, if we're going to do this here, step 1 is going to be find the slope, which is my m value, and then we're going to find a point x sub 1 comma y sub 1. And we're going to substitute in step 3 here, we're going to substitute our m value and our point value into point slope form. And again, remember point slope form is y minus the y coordinate equals m times parentheses x minus the x coordinate. So let's start this off here. Step 1, let's find the slope. This is going to have us going down 2. This has us going to the right 2. Which is going to simplify to be a slope of negative 1. Step 2, it asks you to find a point. And if we remember the top part here, it says other than the y-intercept. We're going to avoid using the y-intercept right now. So that we're going to use this point instead, which is 2 comma 0. That it would be called the x-intercept in this case. We were just trying to locate a point other than the y-intercept. And this is representing my x sub 1 and my y sub 1. Step 3, we are going to remind ourselves that if I want to write this in point slope form, it's y minus the y coordinate equals m times parentheses x minus the x coordinate. As we substitute these values in accordingly, this is y minus 0 equals negative 1 was my slope times parentheses x minus the x coordinate, which was 2. Let's follow those same steps as we take on these last two problems. So, step number 1. Find the slope. I'm going to go up 1 and over 2. Slope is 1/2. We are going to pick a point, not the y-intercept. That is this point right here, which if I count this out on my graph, it is over here at 2. And that's negative 1, negative 2, negative 3, negative 4, to negative 5. Step 3, we're going to write it by substituting in to point slope form. As we do this, I'm going to write this directly on the answer line here. So it's y minus the y coordinate, which is y minus a negative 5, equals my slope, which was 1/2, multiplied by x minus the x coordinate, which was a 2. One more problem to go here. Step 1. Find the slope. Again, we're going to be able to count the slope on the graph. Here we are going down 1, 2, 3. So we're going down being -3 and to the right 1. If I pick a point that is not the y-intercept, my point in this problem here would be right here at 1, 0. Step 3 is to remind ourselves that point slope form is y minus the y coordinate equals x times y minus the y coordinate equals the slope multiplied by x minus the x coordinate wrapped in parentheses. As we write this out here, we will end up with y minus 0 equals the slope was -3 times x minus the x coordinate, which was 1. And again, that there is a wrap on today's notes on point slope form and using point slope form. Have a good day.